This course module will familiarize you with the different types of analyzer and will therefore provide an overview of the different measurement principles. Next, we would like to learn about some of the differences between the measurement systems. We have two different techniques that are used to obtain data: in situ and extractive measurement. For the extractive measurement, we can use different types of analyzers. Analyzers that can operate with hot and wet gases, so-called hot analyzers, and analyzers that can operate only with dry gases, so-called cold analyzers. We will provide an overview of the measurement principles that are applied in the analyzer. You'll remember that in the first part of the basic course we learned the difference between the in situ and the extractive measurement. You will recall that the in situ measurement is a method where the analyzer is mounted directly onto the stack. The measurement is made at actual process conditions: pressure, temperature, moisture, and dust. The measurement system must operate under these conditions. The normalization of the measurement values must be done externally. This means that we need some additional sensors in order to measure temperature, pressure, moisture, and dust. Extractive measurement is a method where the process gas is extracted from the stack. It's transported to a sampling system and is measured in fixed physical conditions. The measurement is not affected by changing the process conditions. We have cold gas analyzers, which can only operate with dry gases, so-called cold-dry analyzers. And we have hot gas analyzers, which can operate with hot and wet gases, so-called hot-wet analyzers. The extractive systems for the hot and cold analyzers differ in that they handle the water content in different ways. Hot systems do not dry the process gas. No cooler in the sampling system. Cold systems can only work with dry gases. They need a cooler to remove the water from the sample gas. They work at a constant dew point, typically at 3 degrees C. Here we have an analyzer system for emission monitoring. It measures cold extractive. Our cold extractive analyzers cannot work with a high dust and moisture content. We need a sampling system to remove dust and moisture. All components are measured in a dry matrix. A typical dew point for the gas after the cooler is 3 degrees C, meaning 0.75 volume percent H2O. The complete analyzer system consists of a probe, sampling system, analyzer modules, system controller, and a data transferring system. Typical conditions for stack gas are high temperature, for example 150 degrees C, pressure, high dust load, moisture, approximately 20 volume percent H2O, 60 degrees C dew point, aerosols. The cold gas analyzers need a dry and clean sample gas. Dry means dew point less than 3 degrees C. Clean means no dust, no aerosols. In the sampling system, dust, moisture, and aerosols are removed, and in some cases, the interfering components are removed as well. Please understand, in our sampling system, we change the gas composition by removing the moisture. By removing the water from the stack gas, the overall gas composition changes. The water content in the stack gas is approximately 20 volume percent, or around 60 degrees C dew point. The water content for the analyzers must be approximately 0.75 volume percent, or 3 degrees C dew point. After removing the water in the cooler, all gas components read approximately 20% higher, due to the missing water in the dry gas. Due to the discharging of water in the cooler, the gas composition changes. When we compare the oxygen readings at the same sample point, for example, we understand O2 measured at the stack, in situ, reads lower than the O2 measured extractive. This method is also used to measure, better to calculate, the moisture content in the stack. The FTIR spectrometer, FTIR stands for Fourier Transform Infrared Spectroscopy, assembled to form a complete system, which is named ACF-NT, also measures extractive. However, this analyzer works at 180 degrees C, so it can measure a hot and wet sample gas. Dust must be removed. However, water and some possible water-soluble components can remain in the sample gas. Hot-wet measurement means that we do not remove the moisture from the sample gas. The gas matrix does not change. The FTIR spectrometer is an extractive analyzer. It measures hot and wet. All components are measured in a wet matrix. We have to monitor the emission associated with harmful components NO, SO2, CO, HCl, HF, NH3, and TOC. Oxygen also needs to be monitored. O2 is not harmful, but the O2 reading is used for calculation, normalization of the emission components. We have different analyzers to measure these components. In addition to the analyzers used for emission monitoring, we also have analyzers only for the process analysis in our program. Different physical measurement principles are applied in the analyzer modules. We have the laser modules for the in-situ installation, cross-stack laser. We have the cold extractive analyzer modules, URAS 26, LIMAS 11 and 23, Magnos 206 and 27, CALDOS 25 and 27, ZO 23. We have the hot extractive analyzer modules, Multi-FID 14, FIDAS 24, ACF-NT. What have you learned in this module? Some general issues associated with emission monitoring. The in-situ analyzers do not need a sampling system. They measure in a wet matrix under process conditions, temperature, pressure. For the hot extractive analyzers, we only have to remove dust from the stack gas. The hot extractive instruments, FTIR spectrometer, FID, measure in a wet matrix. For the cold extractive analyzers, we have to remove dust and moisture from the stack gas. The cold extractive instruments measure in a dry matrix. In the sampling system with a cooler, the gas composition changes. We can use the dry and wet O2 measurement to calculate the moisture content instead of a moisture measurement.